So I'm going to be talking about the James Webb Telescope, that meteor impact that hit it. We've already heard from many people that it's okay. I'll explain really quickly why it's okay. But what I'm going to explain to you is some things that other people aren't able to tell you due to like non-disclosure agreements and some things even being classified. So understand, first thing that I'm going to mention is that the James Webb Telescope wasn't simply put behind the moon in that Lagrange point just because it wants shade. It's not just a heat thing. It's a magnetic field of the Earth that it's also trying to get away from. That's a big reason to put it there. That's actually probably one of the most important reasons to put it there, because more effort and energy could have been put into shielding it from heat, as far as also putting radiators to make sure they kept it cool. But the main thing that they couldn't get away from was the Earth's magnetic field. And this Earth's magnetic field, which I'll explain more in depth, and how this actually causes what appears to be redshift. And if you've seen my other videos, you'll understand that the heat death of the universe, the second law of thermodynamics, how it's being misused. And I'm not sure if I've gotten into why it's being misused, but that gets into a lot of corruption that I'm probably not going to address in this video. So first things first, right? We know that the mirrors are segmented. When you hit one of the mirrors, it's not that big a deal. Not only that, all of the mirrors can adjust in like multiple directions, all the pitch and the yaw a little bit. They also have the ability to go convex and concave, very slight distortions that allows the mirror to really refocus. So losing one segment is something that they planned for. It's something that they thought ahead of time. It wasn't just for the fact that they needed to be able to fold up, because then it would have been, 2 or 3 larger portions. The reason why they segmented it is because of this might be an eventuality. Now understand the apparent redshift, right? Where does that come from? Well, the Earth's magnetic field, we know, distorts light. We know that the Earth's magnetic field distorts light because it's literally what redirects the Earth. When they say that the sun is sending these particles toward us, right, these high energy particles, what they fail to mention is that light itself, when they describe it as a photon, is to kind of keep people in this, I believe it's for corruption reasons, and I have a lot of reason to believe so. But understand that light is simply when an electron moves from a higher energy level to a lower energy level. And so when our magnetic field is capable of distorting the light by sending higher energy light particles all the way to the poles of the planet, this effect doesn't just happen right at that little point where you see the visual images. Just like any magnetic field, right? Where if I have this magnet here, you understand that at some distance, right, it's very strong, it has its force, and if you get closer, it's even stronger and closer. Well, even at this distance where I can't feel it, they're still imparting forces on each other because the magnetic field lines extend out into infinity and then they return back to the poles. So this is why we have this apparent redshift. This apparent redshift just simply because of the fact that the further out we look, the more magnetic field has the ability to affect the light coming in, because it starts from a much, much weaker point, and as it comes in further and further, there is more distortion, so we're able to see it distorting, right? So really quickly again, basically you look out, when you have something that's close to you, it's hitting the really strong part of the magnetic field right here, and then there's that distortion. We don't really see it get to change. Whereas when you're looking further out, you get to see the light as it was. And then it's coming through this weakened part of the magnetic field, which starts to make it look like it's redshifting. And then as it gets closer and closer and closer, it looks as if things are expanding, and it makes it look as if things are expanding more rapidly than the speed of light. So that's simply where the expansion of space idea comes from. And I know it sounds like a lot to hear from someone who's an engineer. Understand that astrophysicists don't actually develop the tools that they use to acquisition this data, which is why they're not really aware of how they work and how simple things are going to interact with it. So most astrophysicists, while they're very educated themselves in space, all this education comes based on the tools that they don't know how to manipulate themselves. And so when you don't know how to build the tool, you're unable to actually make understandings where you go, look, this is how the tool is going to be affected by things. Something else that most people don't really necessarily know is that the Earth's magnetic field that comes from the core is actually an electromagnetic field, right? It comes from an electric current. You might be thinking to yourself, well, where's the electric current coming from? Well, think about the fact that we're able to ground our homes and houses, right? If you understand how electricity works, you know that what happens is that the electrons move from the negative to the positive. And so when we have a buildup of negative charges, we're able to ground that to the Earth. So naturally, right, negative charges are going to want to go down. Those negative charges that go down, those electrons, as they go down, they don't just sit around in the soil, right? Because that would just build up charges. So where do those negative electrons, where do those electrons go? They continue to move down until they hit the core. This is the collision from those electric particles, those electrons colliding is literally what keeps the core hot. It's not the spinning of the Earth. That doesn't even make any sense. The spinning of the Earth isn't capable of churning like literally molten nickel, and like it's basically the collision of electrons. So then now you have actually positive particles as well. If you know anything about chemistry, you know that hydrogen has two oxidation states, right? It has a negative and a positive. In its positive state, that means it has no electrons. It's simply a proton. A free proton is going to act similar to an electron, except in the opposite direction. And so when we do certain things, right, like when we boil water or when we heat things up and we have this separation, there's going to be situations where we're going to have positive hydrogen, right? We call it an ion, I believe, or an anion. I believe, for which way it goes. But as that positive hydrogen is released, it's going to do the opposite of what an electron does. So an electron wanting to go straight down to the core and collide, a proton is going to want to go straight up. This is actually what gives us the reflection that we see off the moon. I know it doesn't make sense compared to what you've heard before, where we believe that it's the reflection of the sun, but just consider the fact that, if the sun is here and the Earth is on the other side, then how would you ever get a full moon? That would assume that light is able to hit the Earth, somehow bend around the Earth, and then light up the moon and then come back. It doesn't make as much sense as when you understand that light itself is just when electrons are changing energy state. It's an electron moving from a higher to a lower energy state. And at night, when we, I don't want to get into the depths of this because this starts to get into biology and a lot of those things. But when you understand now that protons are moving up, and as the Earth starts to spin and things start to change, what happens is the protons and stuff start to make their way back down. These are electrons now changing energy states. The changing energy state is what we're seeing now. This is actually connected, and I probably have to make a separate video where I explain how this is connected to like our women's menstrual cycles, how this is connected to the, what's it called? It's called the, it's basically the circadian rhythm and why people go to sleep every day. Why every animal seems to sleep, whether or not, they're nocturnal or not, they still have to sleep. And this even connects to our yearly cycles. But Earth's an electromagnet. Our biology is part of this electromagnet. The James Webb telescope is put outside into that Lagrange point, not just because it's trying to get distance from the sun and it's trying to be shaded by the moon, but the main reason that they don't tell people about is that they're actually trying to get outside of the Earth's magnetic field. The Earth's magnetic field distorts the light that we're able to see from the Earth. This is why in another video I called it Light at Night, and I forgot the other part of the name, but that Light at Night video where you're able to take pictures, long exposure pictures, and you're able to see other colors, those other colors you're able to see are because the exposure time allowed for some extra light, what would be called photons, but more electrons basically, to make their way to the sensor. And because it's saved as a raw JPEG, it's able to capture more of the data, allowing you to see the sky as it is. These are things that are being hidden from us due to corruption, basically. There's a lot of benefits that come to manipulating us and having us not know exactly how we fit into the cosmos. And a lot of that has to come from us not being able to see the sky as it is. And so that's basically it. If you have any questions, please post and ask them so that way I can add them to a follow-up video. Have a good day.